Hello students. Let's do some problems where we solve exponential equations. Now in order to solve exponential equations you need to have the same base so that we could end up using the one-to-one property of exponential functions, which says that if a is positive but not equal to 1, if a to the x1 equals a to the x2, then x1 equals x2. Let's see how we can make use of that. So for this first example, let's say we're asked to solve 2 to the x equals 8. What you want to do is get your equation to look like this. Okay? Something to the x1 equals that same something to the x2. So what we would say is this. 2 to the x, there's nothing we can really do with that as far as rewriting it another way. However, 8, you have to realize, is 2 cubed. Now look at what I have. I have an exponential equation where both bases are the same. So you, again, using the one-to-one property. If a to the x1 equals a to the x2, then x1 equals x2. So what we would end up with is x equals 3. And what you can do is check. Plug in x equals 3 into the beginning. Well, 2 cubed equals 8. That's true. Let's try another example. Solve 144 equals 12 to the x. So in this case, the right-hand side, there's not anything we can really do. With the left-hand side, 144, I can rewrite 144, the base of 12. Isn't 144 12 squared? Perhaps you remember your perfect squares. 12 squared is equal to 12 to the x. So again, using the one-to-one property, we see 2 is equal to x, which is the same thing as saying x equals 2. Okay, let's try another. Solve 10 to the 2x equals 1000. So I need to rewrite this equation somehow so that we have the same base on both sides. You may realize that 1000 is actually 10 cubed. 10 times 10 times 10 is 1000. So we have the same base, so we're going to use the one-to-one property again. And so we have 2x is equal to 3. So now we just have another step. We're going to solve for x finally, and we get x is equal to 3/2. So let's try another one. Let's say we're asked to solve the equation 9 to the x minus 1 equals 27. Now, for this particular problem, there's more work that we have to do. It's not the case that one side is so simple that we don't have anything to do on that particular side. So what we have to do is we have to decide, well, what base are we going to use? And I think we should use a base 3. Isn't 9 the same thing as 3 squared? And isn't 27 the same thing as 3 cubed? So what I'm going to do is I'm going to rewrite 9 as 3 squared. So what I have now is 3 squared to the x minus 1 equals 3 cubed. Now, using laws of exponents, we raise an exponent to an exponent, you multiply. So what we're doing right now is we're multiplying 2 times the quantity x minus 1. So that gives me 3 to the 2x minus 2 equals 3 cubed. Now we can finally use the one-to-one property because I have the same base. So using the one-to-one property, right, remember the one-to-one property, if a to the x1 equals a to the x2, then x1 equals x2. So a in this case is 3. So what I have now is 2x minus 2 is equal to 3. So add 2 to both sides, divide both sides by 2, and we end up with x equals 5 halves. Let's do one more. Solve 100 to the x plus 2 equals 1000 to the x. So again, we have to get the same base on both sides somehow. So what you have to realize is that 100 is equal to 10 squared, and 1000 is equal to 10 cubed. So what I have now is 10 squared to the x plus 2 equals 10 cubed to the x. Now using laws of exponents, we have 10 to the 2x plus 4 is equal to 10 to the 3x. Now using the one-to-one property, I have 2x plus 4 equals 3x. Well, if I subtract 2x from both sides, I get 4 is equal to 3x minus 2x, which is x. So that gives me 4 is equal to x, which is the same thing as saying x equals 4.